Okay, so this next section is called annuities, and honestly, the simple interest and compound interest, those only work if you just put a sum of money in an account and you don't touch it, and that doesn't usually happen very often. Annuities are more likely to be things that you're going to see or experience in your life. And so, of course, this isn't working. So an annuity is a sequence of payments made at regular time intervals. So some of those could be like you putting in money to save up. So like regular deposits into a savings account. So like maybe every time you're paid, you put $20 in a savings account. Or it could also be things you're paying, like mortgage payments or car payments or any kind of payment that you make the same payment every month. Or also a lot of people have retirement accounts like 401k, or as a teacher I have a 403b, and I have regular deposits that get put in every paycheck or every month or every quarter, as those are annuities. And so there's two formulas here. One of them is called future value of an annuity, and one is called present value. I'm not going to make you memorize these, but you just have to know when to use them, okay? So a future value of an annuity of in payments of $R each paid at the end of each investment period into an account that earns interest at the rate of I per period is given by this. And so, does that say n to the n power? This is the same I that was in the other formula. And so I is going to be the interest rate over the number of monthly payments. And I think in the other one we used M. Is that right? I'm going to go back and look really quick. Sorry. I want to make sure we use the same letters. R over M. Yeah. So I equals R over M, where R is the interest rate and M is the number of times per year. And then when we raise it to the power, gosh, why am I having such a trouble here? The N power is going to be the number of total payments. And so that's also going to be the number of years times the number of payments per year. Yeah. So then N is going to equal M times the number of years if you think of T as years. So it says find the amount of an ordinary annuity consisting of 12 monthly payments of $100 that earn interest at 12% compounded monthly. So R is our starting amount, or our payment. So it's not starting amount. It's like every month we're going to put $100 into this annuity, okay? And then this becomes really important to use your calculator correctly. So this is going to be 0.12 over monthly over 12 to the, well, we're just doing it for one full year, right? So that would be 12 times 1 year minus 1 all over 0.12 over 12. And we'll practice this in class. I'm not going to do a ton of examples here because you have to practice typing this in your calculator. One option is you could just do it like a step at a time. Another option is to use your calculator correctly and a lot of decimals. I mean, a lot of parentheses. The nice thing is 0.12 divided by 12 is just 0.01. And so if I simplify this a little bit, I get 100 times 1.01 to the 12th power minus 1, and I'm going to go ahead and just put that as divided by 0.1 just so I don't have to put another parenthesis in there. And then I'm going to do this all at once on my calculator. Okay, so I'm going to do 1.01 to the 12th power minus 1 divided by 0.01 times 100, and I get $1,268, and I'm going to round to the nearest cent, and 25 cents. So notice you put $1,200 in there because every month you put $100 in it, but then you've gained $68.25 in interest. So this includes your payments plus the interest. The other formula is if you're paying something off, okay? So present value consists of in payments of $R paid at the end of each investment period in an account that earns interest at the same I, blah, blah, blah. Notice this has a negative power. I always remember that the one with the negative is the one that I'm making payments. So this is when you're like paying a bill whereas future value is when you're like investing money, right? Like into a retirement is when you're investing money, okay? So that's how I remember the difference between them. And so look at this example. It says, after making a down payment of $6,000 for an automobile, Murphy paid $600 per month for 36 months with interest charged at 6% per year, compounded monthly on the unpaid balance. What was the original cost of the car? What portion of Murphy's total car payments went towards interest charges? So this one is where we're going to kind of work backwards here to solve this problem. So we know that the payment is $600 per month. It's like a fancy car to me. That's a high car payment. So that goes here. So that's your monthly payment. And what this gives you is P is going to be how much you pay over that time. Okay? So I'm going to do 1 minus 1 plus, and again, I is the interest rate over the number of payments per year. And we're doing this for 36 months. And so you could just put 36 here, or you could say negative. Think about it's, if you want to think about the formula, it's negative 12 for 12 months times 3 years. But then that's negative 36, right? It's nice that they just give us that. All over 0.06 divided by 12. And again, this comes into play of using your calculator correctly and practicing to do this, which if you don't have a calculator on you right now is difficult. But I'm going to do the top of this. I'm going to do 1 minus 1 plus 0.06 divided by 12, parenthesis, to the negative 36 power, divided by 0.06 divided by 12, and then times my payment of $600 a month. And I get that that's $19,722.61 is how much he ends up paying. What was the cost of the car? Well, this isn't the cost of the car because he also put down a down payment of $6,000. So we have to add $6,000 to that to get that the cost of the car was $25,722.61. Well, that's not true, actually, because that's how much money he paid for it, right? He paid $25,722. So that's not how much the car costs. Do you agree with me on that? Because you pay interest. When you borrow money from it, you pay interest. And so how much did he pay in interest? Well, let's think about this, of how we could figure that out. 36 months, we paid $600, right? So 36 times 600 is $21,600. So 36 months, you paid $600. But when we did this, we got 19,722. So if you subtract that, that'll give you how much interest that you paid into that. So 21,600 minus 19,722.61, you paid, or Murphy paid, 1877.39 in interest. And that's why banks give you loans, right? They make money off of it. Okay. Let's look at one more. Where's my time? 9 minutes. Okay. Let's at least set this one up. It says, as a savings program towards Alberto's college education, his parents decided to deposit $100 at the end of every month into a bank account paying interest at a rate of 6% per year, compounded monthly. If the savings program began when Alberto was 6 years old, how much money would have accumulated by the time he turns 18? So first of all, which equation am I going to use? Am I going to use future value or present value? I didn't remember the names of them. I'm going to use the one that doesn't have a negative, right, which is actually future value, because I'm putting money in. I'm not making payments for a car. And so if I use the future value one, I'm going to put $100 in at 1 plus 6% per month. And then I got to figure this number out. Minus 1 all over 0.06 over 12. And so we know that this is 12 times monthly, right? Compounded monthly. And from 6 to 18 is 12 years, right? So we're just going to say 12 full years here. So that's going to be a lot of payments, $144. And so saving money, if you can put some money in to save, that's going to be a good thing to do. And so we'll save this one to see if you can type it in your calculator when we get there. And then we'll practice a few more in class. Okay?